In this video, we'll continue with our polar form of complex numbers, and we'll start right away with this example where we're asked to give the polar and rectangular form of the following complex numbers. Here, we'll start with A and give the rectangular form. So remember, the rectangular form means real, so 1, 2, 3 units in the real direction, and 1, 2, 3, 4, 5, so plus 5 in the imaginary. So there's the real and imaginary parts to make up the rectangular form of the complex number. For polar form, remember we need two things. R, which is equal to the square root of a squared plus b squared, where a is 3 and b is 5 in this case. And if we do that, we get 9 plus 25, and the square root of that is 5.83. So there's R. We also need theta. We find theta by doing the tan inverse of b over a, or in this case 5 over 3. And the tan inverse of that then is 31.0 degrees, rounded to 1 decimal place. So the polar form, we can write 5.83 with an angle of 31.0 degrees. For example B here, we have 1, 2 to the left, so minus 2 minus 5j is the rectangular form. For the polar form, we need r, and that again is going to be a squared or minus 2 squared plus b squared or minus 5 squared. And we go ahead and do that, we get 5.39. And then we need theta, and theta is going to be the tan inverse of b over a, or in this case, negative 5 over negative 2. And if we go ahead and do that, we see that we get 68.2. And this brings us to a very important point. We are in quadrant 3 here. This angle we just found is in quadrant 1. Clearly, the vector cannot be the same if one's in 1 and one is in 3. This is happening because tan can be positive in quadrant 1 or quadrant 3. So our calculator, when we're working in quadrant 3 with the tan function, is going to give us quadrant 1. So to make sure we're in the right quadrant, we need to take our angle, 68.2 degrees, and add 180 to get to quadrant 3. And so that's going to give us 248.2 degrees. Now we're in quadrant 3, and now the equivalent polar form for this rectangular form up here, I'll write it on top here, is going to be 5.39 with an angle of 248.2 degrees. And so there's the equivalent polar form. So remember, if once you do these, you're changing between rectangular and polar form, don't forget to check your quadrants. Both vectors need to be in the same quadrant because we're just talking about two ways to represent the same vector. Add, subtract, multiply, and divide we can do also with polar form, just like we did with rectangular, with a few special rules. Add, subtract, remember we have to use rectangular form, so we've already done this. The key is take what you have, change it to rectangular form, do the addition subtraction like we did, then change the answer back to whatever the question was. So if we were dealing in polar form in this case, return your rectangular form answer to polar form. And you should be able to do that just like we did, find r and theta. If we're multiplying two complex numbers in polar form, we get this nice rule where you can multiply the values of r and add the values of the angles. And we can prove this using some of the trig identities. We're not going to do that, we're just going to give you the formula. So if we multiply r and add the angles. If we divide, well, we divide the r and we subtract the angles. So that's a very convenient way to multiply and divide in polar form. We have a couple of examples then on the last page. So we have an addition here first. So when we're adding, these are both polar form. Step 1 for question 1 is going to be change them to rectangular form. So to change them to rectangular form, remember we're going to have to express them as 1.563 cosine of 37.56 plus 1.5 3 sine of 37.56. And that one needs the I, of course, or J. So that's our first one. And when we simplify that, we get 1.239 plus 0.953J. And we're going to do exactly the same thing for the second part. I'm not going to write it all out. When you change the second one, I'll write it in red, to rectangular form, you should get negative 3.181 plus 2.127J. And that's just by expanding it and working it out. And now, if we go ahead and add those together, we get the final answer, which is negative 1.942 plus 3.08J. And so there's the answer in rectangular form. Of course, we're not going to use rectangular form. We have to change it to polar form because that's how the question was given. So now we need to find r and theta again. So r is going to be the square root of negative 1.942 squared plus 3.08 squared. And theta is going to be the tan inverse of b over a, or in this case, 3.08 over minus 1.942. So left and up means quadrant 2, so we should expect a quadrant 2 angle here, so let's keep that in mind. If we do that, the two answers we get are 3.64 and negative 57.8 degrees. Of course, we don't want negative, we want an angle between 0 and 360. Negative 57.8 degrees, we need to make sure is in quadrant 2, so we're going to add 180, and that's going to tell us 122.23 degrees. So the sum of these two, if we write the final answer, is going to be 3.64 with an angle of 122.23 degrees. So remember, adding, subtracting, rectangular form, perform the operation, convert to polar form, final answer. If we want to multiply each of these now using polar form, and we'll see if we can do it up here. First we need to change 2 plus 3j to polar form, so we need to find r and theta, and we do that using a squared plus b squared, etc. So in polar form, what we get is 3.61 times 56.3 for 2 plus 3j. And for the second one, we get 1.414 angle of 315. So those are our two angles. Once we convert them, we multiply them. That means we multiply 3.61 and 1.414. That gives us 5.105. And the angle, we add those two together, we get 371.3 degrees. Now that's bigger than 360, so we need to subtract 360 to get what we should display as the answer, 11.3 degrees. So this is in quadrant 1, because it's gone all the way around and a little more, so we can represent it with the same angle, which would be 11.3 degrees. So to recap, convert to polar form. I didn't show you the steps, but you should be getting comfortable with that now. Multiply the r values together, add the angle values together. If the answer is bigger than 360, subtract to get the value between 0 and 360. We have two more examples. This next one is actually dividing the same two numbers we just worked with. So the third example there, a, if we divide those two, we're simply going to divide 3.61 by 1.41. And that's going to give us 2.56. And we're going to subtract 56.3 minus this, which gives us negative 258.7. Again, don't want the negative, so we have to add 360. And that's going to give us 101.3. We always can add or subtract 360 as needed, because it gets us back to the same place. That's coterminal angles, which you should be somewhat familiar with. And the final example, we have a multiplication and a division. So we're going to start by multiplying on the top. So 2 times 4 is 8. And then we add the angles. 24 plus 36 is 60. And on the bottom, we still get 16 and 30. Now we're dividing. So we divide 8 and 16. We get 0.5. Subtract 60 and 30. We get 30 degrees. So there's the final answer for that one. In the next lesson, we're going to start with exponential form of complex numbers, do some more examples, work on De Moivre's theorem, and that'll be the end of our first unit.